Okay, hi Braden. So I got your email, so I thought this would be most helpful just to do a couple with you here. First of all, the ones for homework, I believe, were right here 57, 59, 61, 62. Okay. 57 and 59 are really, really tricky. So these are completely not typically what you would find. All right. These are tricky and they require you to remember some properties of logs. Actually, I just looked at 57 here more carefully. 57, this antiderivative, if you would modify it algebraically to do this, to look like this. So what I did was I split those two terms, right? Now, if you look at those two terms, you can just take the antiderivative in reverse. So this is going to be t plus the natural log of t plus c, okay? 59, this is one where you may have tried U sub and I think I cut off the directions, but I think the directions up here, if you read them, it said like play around with it algebraically first. But if you look at this, the indefinite integral of the natural log of e to the x plus the natural log of e to the negative x, okay? Definitely not a derivative rule in reverse, and I don't think there's any U sub that would help you here. Algebraically, though, the log base e of e to the x simplifies to x, and the log base e of e to the negative x simplifies to negative x dx. And then we get this, the indefinite integral of 0 dx. And what's the indefinite integral of 0? It is just any constant. Okay? 61 and 62, I want you to think about, I don't know if I gave all of 61 or not, but 61, they're referring here formulas 5, 6, and 7. You don't have to know what they're referring to, but I talked about the derivatives of the inverse trig functions in class, and it's going to be really helpful if you recall, let's just take a look, the derivative with respect to x of the inverse sine of x, okay? This equals 1 over the square root of 1 minus x squared. This integral is the indefinite integral of 1 over the square root of 9 minus x squared dx. Okay, so when I look at these two expressions right here, if I see this integrand, I see shadows of inverse trig in there, but I have to make some substitution. And this is what we're going to do. We get the antiderivative of 1 over the square root of, here's what I'm going to do. I'm going to factor a 9 out of, whoops, that should be a 1. Out of 9 minus x squared, okay? And I'll get 1 here minus, if I factor a 9 out of x squared, I get x squared over 9. Okay, these are tricky. The U subs that I assigned for homework for tonight are, like, I would say trickier than typical. And I have the indefinite integral of 1/3, because the root 9 comes out, times 1 over the square root of 1 minus x squared over 9 dx. Okay, so this constant factor doesn't worry me right here, because if I want to, as I talked about, I can pull the constant factor through the integral. Why don't we do that? And we can just make sure we incorporate it into the antiderivative later. 1 over the square root of 1 minus, and this is key here, x squared over 9 can be written as x over 3 squared dx. Now I'm going to let u equal, right there, u equals x over 3, or just 1/3 x. So du equals 1/3 dx, or dx equals 3 du. Okay, when I then sub u and dx back into this integral, let's see what happens. I have the 1/3 waiting outside, indefinite integral 1 over the square root of 1 minus u squared times 3 du. And I'm going to do some cleaning. 3's cancel, and I get the indefinite integral of 1 over the root of 1 minus u squared du, and this now gives me inverse sine of u plus c, but u was 1/3 x. So inverse sine of x over 3 plus c. Okay, now that's 61 and 62. All of these here have you playing with the inverse trig derivatives. I think what I'd like you to do is, I pulled some of these, you'll notice these that I pulled through. You know, these are, I would put in the category of particularly tricky, or I would say here, you know, with practice, we'll become more accustomed to manipulating algebraically integrands to give me the inverse trig derivatives. But I think my sense is that you were also stuck on questions like these over here, okay? So what I'd like you to do is, I'd like you to actually try these 1, 2, 3, 4, 5, 6, 7, these 7 right now, and let's see how you do, and then replay me, because I'll do 20, 24, and 28, okay? I'll do those, I'll do this one, and this one right now, but you try those first, and then play me for the answers, okay? All right, Braden, here's 20. So 20, and I think I told you this in class, that whenever there's kind of an inner thing going on, I tend to always try that first for u. So u is 5x, du equals 5 dx, and if you solve for dx, you get dx is going to be du over 5. That's where that is. Clean it up, and then 1/5 tan 5x plus c. 24, interesting, I didn't even notice it when I looked at it before, but you've got an inverse tan situation here. So 1 over 1 plus 16x squared, I could rewrite it like this, like u equal 4x, du equals 4 dx, so, you know, just, you know, I've been skipping a couple of steps here. So dx equals d over 4, sub it back in here, and this just becomes 1/4 indefinite integral of 1 over 1 plus u squared du, 1/4 inverse tan of u plus c. 28 was a great one. Here's that inner again, like that inner. I'm letting u equals x cubed plus 3x, du equals right here. I put it all back in. I want you to look right here. On the surface, someone could panic and say, oh no, my x's don't cancel, my x expressions, right? But look, if I just do factor a 3 out, the x squared plus 1 cancels, and I'm left over with a really nice integral. And then I'm here, and then I'm here. All right, so Braden, I hope that helped out. Why don't you try the rest of those? Those are evens. What you can do is you can hand me tomorrow, and I can just check them and see if you were right. Okay, I hope that was helpful, and I hope you're having a good weekend. Bye.